Hey, bonsoir. Je m'appelle Maria Pere-Perez. Je parle un petit peu français. But it's been a long time since I had university French. Just to introduce myself, I work for Databricks. I have come all the way from San Francisco to be here and enjoy the lovely weather. Yes. And my coworker here, Ron.
Hi, I'm Ron Guerero. I'm a solutions architect for Databricks. I'm actually based out of Toronto, but I cover the Great Lakes region, so not even covering the Canadian kids.
So I noticed they're serving burritos, which is funny. I was talking to someone here. I was saying burritos is a San Francisco invention, the way you're eating it, actually. Originally, the burrito from Mexico only had meat and beans, but then if you add the rice and the sour cream and the lettuce, that's San Francisco, actually. So glad that you like San Francisco food. So I'm here today to talk about Databricks and ETL pipelines and how we work together with Talend. So Talend is our strategic partner, and you can tell I'm very committed to come here from all the way in San Francisco in this lovely weather. And so today I'm going to start with talking about AI, right? So AI is the big hype. Is there a lot of AI happening in Montreal? Yeah? Okay, good. So the thing we know about AI is it's a competitive differentiator that helps companies, and companies can do better analysis of their customers, or they can do better fraud detection. Like we have a customer, Capital One. I think it's costing them something like $8 billion a year to have credit card fraud, and so we were able to improve lower that number a little bit. So we've saved them millions of dollars.
How much did you say? 8 million or 8 billion?
Billion, yeah.
8 billion?
Yes.
It's Capital One.
Trump's bank, right?
It's not community.
So we know that organizations that use AI, they do outperform, right? So companies that have taken advantage of AI have doubled their operating margin, and they, at least on average have about $100 million in additional income from the larger companies. But only a few companies are able to do this, right? These are the 1% that are truly successful with AI. And what we want to do together with Talend and Databricks is to make it so that you guys can also get the same types of returns. Because the struggle with AI and machine learning is really around all the data and the silos that go around it, right? So you've got hundreds of data sources. You've got your data warehouses. You've got your cloud databases. You've got CRM software like Salesforce.com, you've got SAP, you've got ERP, all needing to be brought together. And then on the other side, you've got data scientists that want to run algorithms with it. So you've got these separate silos with data scientists and data engineers. And the hardest part of AI, it's not the data, it's not the machine learning code, it's the data around it. So the AI part is really tiny, but everything around it, that's what you have to work with, right? So the combination of Talend and Databricks together makes this easier for you. So by the way, I'm just the warm-up act. The real demo is going to come when they come on. So I'm just going to give you a small overview of who Databricks is. How many of you have not heard of Databricks? Okay. And how many of you think that Databricks is just open source Spark that's hosted on the cloud? Thank you for raising your hand. So we're more than that, actually, and I'm going to talk about how we're better, and you're going to show them how. So Databricks was started with the mission of helping data experts with solving really tough problems, and the way we do that is we want to accelerate innovation by removing the silos. So combining the data scientists, the data engineers, and the line of business. in many companies, they are not just very different divisions and roles, they're also very different personalities. So we try to bring them together in a single unified analytics platform. So we were founded by the original creators of Spark, and they developed Spark and donated it to the Apache Foundation. And then they developed the next thing, and the next thing is called Databricks Delta, which is a unified analytics engine, and it's actually sort of like a Spark on steroids, and you'll see in a moment what that means. Then they also created MLflow, which is a platform for machine learning and AI. So, so we've created this unified analytics platform, and this is what it looks like. There's 3 layers, actually. So the delivery layer is the fully managed service on the cloud. We partnered with Microsoft Azure and Amazon Web Services, AWS, and so we were born in the cloud, and what we offer is a service that's fully optimized and auto-scaling. So you don't have to think ahead of time, hey, do I need 10 nodes or do I need 100 nodes? It'll automatically build and configure for you whenever you need it. And then we've got the operational layer, which is the Databricks runtime. So, as I mentioned, we do have open source Spark, but we do have the unified analytics engine, which is the next generation of Spark. And then we also have machine learning frameworks in there, like MLflow, which I mentioned earlier. We also have TensorFlow by Google. So any machine learning framework you want to use is available in our platform. And then we've got the innovation layer, which is the workspace. This is where the magic happens. So this is where your ETL pipelines can get created and processed. This is where you build your models for training. And you can do it in a very collaborative space. It's so easy that even a salesperson can use it, right? So the notebook is basically, it's like a Google Doc, and you can have 10 or 100 data engineers all entering code. And then you can also have Talend creating the code and entering it into a notebook for collaboration and doing production with. Am I explaining that right? Anything else? Okay, and then so Databricks Delta, what I want to say that makes us different is you've got all kinds of data with all kinds of schemas, right? And the problem is, when you put it into a data lake, it's not always super reliable. So Databricks Delta makes it reliable by enforcing schema and enforcing ACID transactions, and Ron can talk about what that means more. And then also, we are also faster than just open source Spark. 10 to 100 times faster. So open source Spark is already faster than MapReduce by 10 to 100%. So if you add this, you're like 1,000 times faster when you process. So 2,000 customers are using us, and we are across all industries. So as you can see here, we have a few Canadian customers that we can talk about publicly, like Flipboard. We do have a couple dozen Canadian customers, actually more than that, probably, I think more than that. If you'd like to learn more about what we do in Canada, I'm happy to arrange a meeting with our salespeople who can tell you more about what we're doing at other companies. All right, want to talk about Talend?
Yeah, sure. So I forgot to introduce myself before. So Adrien Lacombe, I'm the solution engineer manager for this, what we call the Central region, which is basically the Midwest in the US and Canada. So quite a small patch.
We missed the slide.
We missed that one. That's interesting. Yeah, it's kind of a missing one.
Oh, sorry. We accidentally deleted one slide, but you can talk about Talend.
I can do the right side, right? No worries about it.
Yes.
So you know what? I'm going to do that, and then you can switch back to the one before.
Yeah.
So for those who don't know Talend by heart, one of the key differentiators, especially in that space, is that we will bring the connectivity, the Talend connectivity. Look, we have like 900 connectors component to bring data inside the storage that you need to use under Databricks, all right? So whether it's Azure or Amazon, so that'll be one differentiator. The other thing is when you bring the data, you need also to do a lot of preparation before the data is ready to be used for machine learning. And that's where instead of using scripting language, then Talend will bring a lot of graphical tools to cleanse, standardize, match eventually, enrich the data, do whatever you need to do before you actually build your machine learning model or score the data you need to score. All right. It's also the only platform in the market that is sort of big data native in the cloud. So for those using Talend Big Data, for example, with EMR or with other Hadoop vendors, we do generate Spark code. That will be the same with Databricks, right? So because they leverage Spark natively, and we do generate Spark natively, so we added the support of Databricks as a runtime 9 months ago, something like that. So it's a key first stop partner for us. So we'll be able to build pipelines that actually will natively execute inside the Databricks cluster. Whether it's Azure or Amazon, by the way. And the last one is not very technical. It's much more about the way we facilitate the access to the technology. Is whether you work on a small pilot machine learning project or a huge amount of data that will be in production every day. Basically, the limit will not be Talend, right? It would be will be priced per developer and not per connectors or volumes or nodes or whatever. That has nothing to do for us with the price. So that will make your life easier when you have to. Basically, the limit is your brain in that case, not Talend. All right. So I'll come back to that one, so you can actually
all right.
talk through it.
So how do we work together? All right. So think of ETL as having two components. You've got the design component, and then you've got the processing component. So how many of you are data engineers? How many of you like to code? Okay, there's a few. Do you have time to code?
Not time to code, just not to debug.
Okay, there you go. So if you use Databricks, you can, on a notebook, manually write out the code, all the code, and you have to think about all your data sources. So that's a lot of code, right? Or you could use Talend, which is a GUI, drag and drop, very easy to use interface, and it'll create the code for you, right? And put it into a notebook and work. But in either case, though, the processing part will happen on Databricks. Processing right now can happen on EMR, it can happen on Cloudera, but the processing of the ETL workload will happen in Databricks. For ingestion into other data destinations. All right. So actually, I'm going to skip this slide. I'm going to talk about, this is our joint customer, Uniper. It's an energy company based out of Dusseldorf, Germany. They provide power to 40 countries. They also do, I think to make additional money, they do trading around just goods and electricity. They do some trading. But the problem with being an energy company is, there's been a big deregulation. There's a lot more competition. And so their goals is to stay competitive. They needed to improve their operational efficiency. And the way they can be more efficient is by providing their analysts with data in real time. So they want the data to come in real time to the line of business user because they want to improve processes around capital planning, also on power generation, should it be centralized or decentralized, what part makes more money, and just general business operations. So by using Talend and Databricks together, it's 80% cheaper, so they've saved money. It runs 75% faster, and there's a 50% gain. All right, I'm going to give this now to Ron.
Great. So with Talend and Databricks, what you're getting is a very powerful yet simple solution that allows you to build serverless, scalable data pipelines. Now, in my past life, in my big data career, I was a consultant working with a lot of financial services customers who were using already Spark. And the end game of their use cases is to do data science Data engineering was something that they had to do just so the data scientists can actually work on the data, build their models. So they had asked us, how do you make things a lot easier to be able to get to that end state so my data scientists can be productive? And so that's where we saw a huge benefit where a tool like Talend can actually help them out. Because what you're now doing is moving all of that up, simplifying it with an interface that allows you to build data pipelines graphically. And I think you guys are already using it, so you know how great it is. So from your perspective, you're not going to see any difference from creating your pipelines when you're using Databricks. What you will see is the ability to still leverage the 900 or so connectors that you have to get the data wherever it resides, the ability to, within the Designer Studio, drag and drop, build your complicated workflows, your data processing flows, yet have it automatically converted into native Spark code and launched on a highly scalable Spark environment that's Databricks. So as Maria alluded to, you don't have to worry from a Talend developer perspective, the size of the cluster you deal with. It will automatically recognize the workload that it has to work with. Oh, I need more, I could benefit by more CPU, more servers being spun up. It will auto scale. It'll also recognize that, oh, in this part of the pipeline, we don't need these worker nodes anymore. Let's remove them. Or even recognizing that, oh, this job is finished. There's nothing else that is running on this environment. We can take it down. And what's great now is when you use Talend to get the data, to make it available for Databricks, it enables your data scientists to do the real work, which is doing machine learning development. But on top of that, we also enable people to do exploratory analytics on the data. Once it's in Databricks, you can connect BI tools like Tableau into a Databricks cluster. So it's just like another database system to them. You're doing ad hoc analytics against it. And then if you have a need to then push artifacts that you already have in Databricks out to another system, you can tailor that in another Talend workflow that pushes it out to the numerous data targets that are available. So we're going to walk you through a demo at this point, but I'll give you a little bit of a preamble in terms of what this demo will be all about. So the use case, the scenario is we're working with a financial services type company. They're a credit processor. They're sitting on a wealth of data. The CDO has identified that, hey, we want to monetize this information. Specifically, let's build some fraud analytics products. Let's do some predictive analytics around fraudulent behavior. And it's a way for them to upsell products to the banks or to the card issuers that are on their network. It's a way to reduce risk, liability, and improve customer satisfaction. However, there's a few challenges that they're dealing with. There's a lack of skill set in terms of dealing with the big data environment. They do have some Spark skills, so the data scientists are familiar with some of the ML frameworks that are out there in the Spark world. Yet they're also faced with capacity issues, running their data in an EDW, enterprise data warehouse, where it's running at capacity. And what they're looking for is a solution that's easy to use, so drag and drop where possible, also leveraging existing skill sets. So SQL is something that most people know in an organization. If there's any ways to be able to re-leverage that, but more importantly, moving everything out into the cloud. They recognize that's strategic. It's very difficult to maintain infrastructure on-prem, to scale it out. It's more cost-effective and simpler to do so in the cloud. And this is what their current infrastructure looks like. They've got a payments network. There's point-of-sale systems. There's those card chip readers, as well as systems that are attached to a brick-and-mortar bank. That data is being fed into an on-prem environment. There's an enterprise data warehouse that we mentioned is already running at capacity to the point where they can't keep all the transaction data in the EDW. They actually have to age out or push some of that data into cheap archival storage. We'll say it's tape in this situation. So that data is lost from an analytics perspective. They're also working with dimensional data, their product database or their ATM information. And right now, a lot of their analytics are just done with existing BI tools. There's no machine learning that's happening in this kind of config. And then on top of that, they've got a cloud environment. The CRM information is coming from Salesforce, and there's challenges in getting that for use for analytics. So this is a proposed architecture that we're going to go through. The payments data still flows to the on-prem environment. But what we've done now is we've removed that cheap archival storage. All that data can be pushed into the cloud. Specifically, Talend is going to push that information and make it available for machine learning, for analytics. Talend is also going to be able to pull the latest transactions from that EDW as well as any dimensional data. It's going to push all the processing into Databricks to do the data transformations. It is going to be available. Your data scientists can build the fraud models that we talked about and make those assets available, or the results of that analysis, to end users. It's also going to leverage Talend to pull that information from Salesforce. Quite simple to do with one of the connectors they have and bring it in for the work that we're going to show in the demo. So we're going to go through a series of components. So we'll actually show you, the Designer Studio. We'll show you the Databricks notebooks. But real quick, what that flow is going to look like, we're going to grab data from on-prem. So this is the transaction data, the dimensional data. It's going to append that. It's going to add that into the full historical transaction data set that resides in the cloud. It's going to then join, it's going to enrich that transaction information with customer data from the CRM systems, Salesforce. It's going to do some cleansing, some aggregation, some masking, making that data available for Databricks. Now from Talend, you have the ability to execute Databricks notebooks. So we're going to execute 2 of them. One of them is to build and train a model. You typically wouldn't do that in this kind of flow, but it's just to show you that there is that integration. You have the ability to control and submit things and orchestrate things through Talend. And then the other notebook that I'm going to show you is making predictions against a new set of transactions. Did fraudulent activity happen, in producing a data set that could be consumed by a business user. And all of this is going to be, all the heavy lifting, all the processing is going to be pushed down into the Databricks cluster. So now for the demo itself. And we're going to start from the very end and then take you back to the beginning. So you'll see the light at the end of the tunnel and what we're trying to show and the business value that you can get with this kind of a solution. So as I mentioned, at the end, we're trying to predict fraud. And so the data set that our business user wants to see is, you've fed in, latest set of transaction information. Can you tell me which transactions look to be suspect? And so this is the data set that we're gonna see. You can see that it's got the information about the customer, whether there's a withdrawal or deposit, where the transaction happened to occur, but also prediction value. So this is what's going to be filled in by the execution of the model.
Might it be possible to zoom in?
Oh, sorry, I apologize. How about that? Does that look better? Awesome. So that's one artifact that we're going to see. The artifact,
Oh, there is a room right here if you want.
yeah, that's true. Yeah. the thing that actually helps with that prediction is going to be essentially a decision tree classifier. So it's in ML, machine learning speak. It's something that you can use to model a particular behavior. And so I don't want to go into too much of the details, but this is what the visual representation looks like. Each of those nodes represents specific attributes about a transaction, about a customer. And as it's trying to figure out whether or not something is fraudulent, it will basically go down this binary tree. At the very bottom, there's a prediction that says it's either 0 for a regular transaction and a 1 indicating that it looks suspicious. But how do we get to this point? How do we get to the end game of providing something to the end user and building models? We need to get some data from Talend. So Talend, and Adrien's going to show you this. He's going to go through a workflow that produces 2 data sets that Databricks is going to use. One of which is like a business analyst view. It's an aggregated representation of the data, top 5 customers that were defrauded. We don't need that for machine learning, but it's a great thing to show to a business analyst or a business stakeholder who wants to identify key customers. The other data set that I do want to show you is the Customer 360 data, which is the transaction data that includes customer information, area of residence, as well as mask card numbers. We don't need to, actually look at that, but it just showcases the fact that Talend can mask that for you. Now, the last thing I'll point out is this is a data set that we're going to use for training. So we want a data set where either a user has already came in and identified transactions as fraudulent or not, or if there was an upstream machine learning pipeline that correctly identified it. Essentially, we want to feed this into our algorithm that will then build that predictive model. So this is the two assets that Talend will provide me. So I'm going to hand it over to Adrien, and he'll walk you through the Talend pipeline that gets us to this state.
Now?
Yes.
All right, thank you, Ron. All right, so let's open it, and I hope it's going to be good enough because we don't have a Mac, so we don't have the Zoom possibility on the studio, all right? That's the only missing thing on Windows since 15 years, but let's do it like that. All right, so since you're users of Talend already, you know everything about the studio. I would just expect that and assume, but based on Eclipse, I can work with Git, everything about the collaboration. So I will skip that part and just focus on the pipeline itself and the value in that specific use case. So here we need to bring the data from the on-prem transactional data, the point of sale data. So for these use cases, the data will be sitting in actually in a SQL warehouse, SQL server in the cloud, as well as it's been dumped from Salesforce to a file. So here we're leveraging a specific type of job called Big Data Batch that will generate Spark code. So here, if you go in that specific one, you will see that the framework uses Spark. The connectors are the one same as a standard job. So we'll be using a SQL Server JDBC connector to connect to a product data set. So the raw data sets is here. If I look at the data, it's just information on the product themselves. So you will see from far customer ID, card number, shanking and saving flag, just to flag the type of account. We got SQL Server, the location of the point of sale, so mainly where it is, what ATM we're using, where the transaction history came from. All right, and all the transaction history will come from that database. So we're just putting that into a Parquet file. So those components are specific to put that into a Parquet format. Reason we use that is because Parquet will be much easier, much performant instead of analytics for the analytics on the later side. So we're generating these three files, all right? And if you look here, I'm just creating a specific file called products here in a fraud folder, and it's writing it into ADLS. So here in my Spark, I have a specific Azure file system configuration, and because we put that storage configuration component, then the job knows that the output will be in Azure, data lake storage in that case, all right? If you actually remove that component, it will write into Databricks file system by default, which is the default one that the Spark engine will be using. This other component is just to give the JDBC configuration for the SQL Server, the database that we use. So once we have all these data sets created, then we will merge the transaction together, all right, it's just two Parquet file, enrich that with the location of the point of sales and the product. So we got these 4 data sets, and some are lookup, some are just join. So the just classical TMAP component to do the mapping and merge normal. If you were using just the ETL from Talend, that would be the big data part of it. It's just the same design. Most of the components are common. And here you can still put your own Java code if you want and put the transformation, all right? And then we create this transaction point of sale product join data file, all right? The main difference here with the standard job will be that in the Spark configuration, so that will tell Talend where to execute that. And that basically here, we have a specific Databricks target. We specify the version of the cluster and the version of Spark we'll be using. So if you were to look at the Databricks configuration, there is a notion of cluster. All right, so we can have multiple purpose dedicated cluster. So we will we'll use this one. Specific endpoint. So Databricks has endpoints in every region of Azure, as well as Amazon.
Sorry,
Yeah.
so you're saying that basically be run like on any other environment. You just have to select something else than Databricks, and these same parts, like you
Yeah.
stay the same, and run on another environment.
Yeah, that's the idea. Yeah. In Databricks, in the cluster, it still needs to be able to access the data lake storage. So the cluster will be configured so it will mount the data lake storage as a local, like if it was actually its storage, okay? So that's a configuration to do at the Databricks layer. But if you were to have like another Databricks cluster in another region, you can still just point it out to the other cluster as long as it's configured correctly, all right? That's the idea. So that's just the authentication information. We won't run it like, we have run the job just before coming here, all right? So I won't do that part here, but that will be the same as standard job. So you got the job, debug, run, and all the stuff available. So the second part of the job is actually just a simple one. It's just retrieving the Salesforce data, do some enrichment, so that will be the customer information. So we will enrich the transaction information with real customer information, like the name, first name, or whatever location. We put that into a local file, and we will push that to Databricks file system. So here it's really for, you will probably not do that in the real world. What you will do will be to probably push that into the data lake store as the others. It's just to show you that we have dedicated component for Databricks file system, and we could put that as if it was an HDFS or S3. You can put that directly into a Databricks file system. Then comes the enrichment of a transaction. Here it's a Spark job again, just some classical dropping some, pushing some SQL, dropping some table here. Same for the second step, so nothing complicated. We will take the resulting data set from before and enrich it with the Salesforce data that we have put in before, so we can actually enrich it. So if I look here, I will have this join done on the customer ID, and it will enrich with name, first name, and last name, and just take the raw data plus the enriched data. All right, creating this CRM enriched data sets. All right, and everything is again running at on the Spark cluster level. Then here, that's the part where we create the two resulting data sets. So remember that screenshot is actually the one that we put into the notebook inside Databricks. So inside Databricks is just to represent graphically the screenshot so you understand which job, what the other job is doing. Same here, we point to the same ADLS data lake store Gen 1 endpoint. We will take the CRM enriched data set in Parquet. Here, that's a component that will replicate the data in two different lines. So we basically replicate the data. One will create the top 5 defrauded data set in Parquet. The other one will create this customer 360 data set. Difference between here and there is here we create an aggregation. So there is an aggregate row component. It's just calculation, average, sum, whatever. If you were to put your own SQL Spark code here, you will use a component called T-SQL row, where you can actually create your own SQL code inside the code, so you can work directly on the data frame in the job. That's pretty powerful, so that's a hint for you. This is like a top 5. You just take the top N lines, and that one is doing aggregation, is doing sorting as well, but it's also doing some cleansing. So we're trimming the location columns here. So just simple function that we use inside the pipe. So that will be the preparation aspect that you need to do before using the machine learning, for example. Okay, and this is a masking component. So if you don't know the existence of that component, it's called T-data masking. It has a lot of function to actually obfuscate the data. So it will keep the meaning of the data, keep the format, for example. You know, it's a standard phone number. It just keep being a standard phone number, but with a different value. All right, so you don't have to actually expose the real data, but can still do analytics on it. And then you create the resulting data set. So at that point in time, the user has used Talend to, retrieve the data, push it out to the data lake store, enrich it, and cleanse it. Okay, so that's what Talend is very good at. It could have been every source, basically, whether it's on-prem or in the cloud. And so that's the time where now it's time to actually train the model or build the model if it's not done yet with Databricks using notebooks and encoding in that case. And then if you already have the model created, you can actually use Talend to execute the notebooks on the new data coming and actually score the data based on the model. So you can have that last step that actually calls notebooks if they exist directly. So just a REST call in that case. If it's already created, that's just a REST call in that case. But at that point, it's probably better to see what those notebooks does before I go forward.
So how many of you guys have worked in a notebook environment? Nice. So how about IntelliJ or any of those like PyCharm or any other standard? Okay. So the one thing that's great about notebooks, for those of you that haven't used it, is everything's very graphical. I can incorporate very nice, visualizations as part of the notebook. I can actually, pull in graphics as you saw over here. I can, do some interesting markdown, within cells. So when you actually put your code in cells. And the other thing that you can do is, if there's any artifacts from, say, running a SQL command, you get these nice charts that actually, come out as well. And it's a REPL environment, read, evaluate, print, loop. I can code some things in a cell. I could run the cell, see the results, and then use that as a guiding way to see, am I developing my flow correctly? Is this what the data looks like? Can I validate what attributes I can use for my machine learning development? Now, the interesting thing about our notebooks compared to, I guess if you guys have used notebooks, Jupyter would be something you guys had played with. So you get a similar interface you get with Jupyter, but ours is more enterprise grade. You can have concurrent users accessing the same notebook at the same time. So Julian's working on it, and Adrien decides to code different cells. One cell is for data prep, one is more modifying the model. Totally capable with you. And it's similar to Google Docs, as Maria mentioned. You'll see little icons that indicate that who is actually in the code at this moment. But to make it even more enterprise grade and easier to collaborate, we've got revision history. So if Julian was to modify something, I'll actually see his name pop up as well as a date. I can see what changes he made. Likewise, if Adrien is doing the same thing, and you can actually natively integrate this with Git, so I can actually synchronize any of my changes into to GitHub, GitLab, or Azure DevOps. Going along the same vein of collaboration, I can also have users that are working on the code to add comments. Let's see if I can, with this zooming I might have lost, yeah. So data engineers, data analysts, data scientists can collaborate with each other and identify, pinpoint specific areas where it might need to be fixed or there's questions around it. You can also schedule these notebooks to run. So once you've built it, you have the ability to have it automatically run or triggered based on some time window. So back to the actual use case that we were talking about. We've got the data provided by Talend. We showed what this pipeline would look like, where the data is coming from. Talend is landing it into cloud storage. Now, Adrien alluded to DBFS, or a file system specific for Databricks. You can think of it as just an abstraction layer for storage. Realistically, the data itself will reside in cloud, whether it be S3 or ADLS, Azure Data Lake Storage, or Azure Blob Storage. And you're just essentially mounting it so that, to us, it looks like a regular file system and it can access it like it's almost local. You can see the various data artifacts that Talend had provided. And as a data scientist, I might be wondering, well, what does this data look like? Well, it's as simple as running a simple command. And actually, this is what I wanted to point out as well, is in a notebook, you might have Python as your base language. You can actually switch up your languages within a cell. So we have the notion of magic commands, where as an analyst, I don't really want to write Scala or Python code to understand what the data looks like. Can't I just use SQL? Well, I'll flip the language to SQL, do a simple create table statement, and I know because the underlying data files are Parquet, as Adrien mentioned, that has schema already built into it. So when I run this command, I can immediately do a select and I'm able to look at this data. So quite simple. This was the top defrauded customer. So as a data scientist, maybe not as important to me, but I'm going to show you how we can produce these artifacts for for a business analyst. I'm more interested in this customer 360 data set, which is the enriched transaction information. So I'm going to do the same step that I did before. Simple SQL command, point it to the data that Talend provided. This is the enriched data set. And I can start seeing the various attributes, the various fields that are available. And so as a data scientist, I could be thinking, what fields do I want to include in my model? And if I wanted to, I can also create some other fancy charts if I want to see distributions of the data itself. But here's the more interesting stuff. We're going to actually start building the model. Here we're going to be using Spark ML, so machine learning libraries that are pre-built with Spark. This first step, I don't have to go into the code deeply, but we're identifying which fields we want from the data up above we want to use when we build our model. So whether it was a withdrawal or deposit, if it was a chip versus a swipe, with whether, what bank it was done, the amount, and when that transaction got processed. In this code over here, we're basically saying we want to build a decision tree classifier. So it's a classification problem. Is this transaction good or is it bad? So this code basically takes those attributes that I mentioned up above and will feed that in as input of data that we want to use in our classifier. Here, what we need to do is work with the training data. So the training data is the data that Talend provided, and in that data, we know what the answers are. As I mentioned before, transactions were flagged or set in terms of were they good or bad. But I want to split that data into two. One I'm going to use to actually train and build my model. And the other, I'm just going to validate the results to see if the model is accurate. So I split into two sets, a training data set, a test data set. And then this command actually builds the model itself, and then I run some predictions against the test data set. And I can see what that prediction looks like for that, the test data set. And I can then serialize, write that model that was created by all those APIs into cloud storage that can be called in another notebook. So I've built a model. It's basically, you can think of it as a predictive function. I give it some input about the transaction, about the customer, and it'll tell me if it thinks this particular transaction is fraudulent. And this function, if you will, is now persisted to disk, which allows it to be used by other processes, and more importantly, it's going to be used by the other notebook. Now, one thing I do want to point out, what's great, from a data scientist and a data engineer for collaboration, the fact you can do all these great things with it, is a business analyst coming in might not make heads or tail of the actual code itself. So, speaking to the point that Maria made about unifying the various personas of those that are building data pipelines, you can build dashboards within Databricks, where essentially it will grab all of the graphical elements within the dashboard itself. You can move things around. In this case, we don't care where the data came from, but the analyst might be interested in the top 5 defrauded accounts. And they might be also interested in knowing what the data flow looked like from Talend. And now I can present this as a dashboard to a business user. And they can easily update it in case Talend sends new information. This button will update the graphics that you see on the screen. And all of this is all locked down security-wise as well. So we lock into single sign-on. So if you're Azure Databricks, then Azure Active Directory, and then AWS, you can connect to one of the many SSO single sign-on providers that are out there. So this is building the model. We've created something. We've persisted it to disk. Let's look at the other notebook. So high-level steps. We know we're going to be dealing with new sets of transaction data where we haven't predicted if it was fraud or not. We had created a model in the previous notebook, so we want to load it, and then we just want to run that model against this new data set. So the first step is to pull in the new transaction data. So here, Talend would have provided us this information, You'll notice if we look at the actual contents, there's no fraud field. So this is a new data set that we want to do some predictions on. We load the model from cloud storage. And essentially, we run the scoring. And the output of it is essentially a temporary view, almost like a table, which can be, you can now run SQL commands against. And similar to what we did before, you can build a dashboard that this artifact over here can be presented to a business user. So the one quick thing that I do also want to show is, Adrien mentioned the fact that Talend is going to leverage a cluster within Databricks. Databricks introduces a different notion when it comes to Spark clusters compared to Hadoop, in that you can actually have multiple clusters spun up. In a Hadoop environment, it's just one Spark cluster essentially that you're running. And this allows you in Databricks to do better process isolation. So if you've ever worked with environments where customers want to do SQL access to big data, yet they also want to do streaming on the same cluster, and they also want to do data processing, they want to do data science, they start to collide with each other, they start to contend, and you start seeing performance degradation. With Azure Databricks, you can spin up, or Databricks in general, you can spin up any number of clusters for particular business use. So one for streaming, one for data ingestion, one specifically for Talend to use, one for analysts to use when they connect via Power BI or Talend, because they want to run SQL queries against data using Spark SQL. And to create a cluster, it's as simple as just providing a name, a cluster type, if you expect there to be a lot of users connected to the same cluster, or is it more of just a batch job that you want to run, and then specifying the scaling parameters. When you spin up this environment, you can say, well, always keep this minimum number of Spark workers, and scale up to the maximum that you identify. And as I mentioned before, having the system automatically detect whether or not it needs to introduce more worker nodes or scale them down. And then there's also a auto terminate. After a certain period of time where there hasn't been any activity, you have the ability to bring the cluster down and save on cloud costs. So Maria mentioned in one of her slides this notion of our packaging of Spark. And we do that in something called the Databricks runtime. So there's multiple versions of the runtime that's available to you, and they're tied to a Spark version. So what's great is if there's a new version of Spark that's available, it's as simple as changing your cluster config and choosing a newer version. Some of the ones have a ML tag to it, which refers to the fact that this is a machine learning Databricks runtime. So all those machine learning packages are prepackaged in this environment. You don't have to fiddle with installs to get TensorFlow or to get Horovod or to get PyTorch up and running. It's readily available for your data scientists to use. So it alleviates all of that infrastructure and DevOps type work to get that environment prepared. And then finally, when it comes to choosing the types of machines you want to use, it's quite flexible and it depends on how much you want to pay. The beefier machines obviously will cost a lot more, but you also have the ability to use GPU accelerated instances if that's your use case. So for like TensorFlow or Horovod, if you select a Databricks runtime that has GPU capabilities, you'll have access to those systems. Okay. So we'll circle back. In this demo, we want to show you how you can simplify your data ingest using both Talend and Databricks, and having the ability to scale the processing at will, when you're connecting Talend to Databricks. And with this combination, you have the ability to get the right data wherever it resides, to the right people, and enable your data scientists to focus on what they really want to do, which is, again, building those machine learning pipelines. And with both of our technologies and how easy it is to get started to do your work, it allows you to get to your big data initiatives faster and at less cost.